In 10a, it's another quadratic or polynomial inequality. So take the same approach. We want to make sure that we get one side equal to 0. I'd like to keep my quadratic term positive. So negative 12x and then plus 9 has to be less than or equal to 0. So I think this thing's going to factor. I'm going to go ahead and try to factor it. 4x squared. I'm looking at this as a trinomial square, so I think it's a 2x. A 2x, the signs have to be the same, and they both have to be negative. Now if I go 3 and 3, I get a negative 6x, which is a negative 12x. So that's factored. So really it's 2x minus 3 squared. It has to be less than or equal to 0. So on my number line, I want to locate the location of the 0, and this is only 1 0. It's at a positive 3 halves. And when we put in a positive 3 halves, we know it's going to equal 0 because that is our 0. And the squared tells me it is tangent at that point. So it's going to be tangent at that point. It's actually going to touch here, but never cross the axis again. So they're asking us, where is it less than or equal to 0? Well, this graph is never less than 0, but it is equal to 0, and that is when it's at 3 halves. So my solution set is a singular number, just because that's the only place that it satisfies the inequality. So that's how I'd approach that one. You can still do your interval line test and run through that, and you'll notice that you'll get positives and then positive, and then a 0 in the middle, which again, it's a matter of interpreting your inequalities.